Welcome to Maths for You channel. Another past question on integration from Oxford and Cambridge past paper. Question, part A. Use a substitution u equal e to the power x minus 2 to show that integral 7 is to the power of x minus 8 over e to the power x minus 2 squared, whole thing squared, dx equal integral 7u plus 6 divided by u squared times u plus 2 du. Part B, hence I show that integral, the upper limit is ln 6, lower limit ln 4, 7 e to the power x minus 8 divided by e to the power x minus 2 whole thing squared dx equal a plus ln b, where a, b are rational numbers to be determined. Okay, let's start with the first part. The substitution given u equal to the power x minus 2. All you have to do is just substitute or change x into u. That's all we have to do it for the first part. So I just call it I, integral 7e to the power x minus 8 over e to the power x minus 2 whole thing squared dx. E to the power x equal u plus 2 from substitution if you take u 2 to the other side, so e to the power x equal u plus 2. So e to the power x can be changed into u as for done. But the dx we need that, so differentiate both sides of the e to the power x plus e to the power x equal u plus 2. That will be e to the power x dx on the left hand side, the right hand side just du because of the differentiation of 2 is 0. So from that dx equal 1 over e to the power x du. But e to the power x, we need to change everything to a u. So dx equal 1 over u plus 2 because e to the power x equal u plus 2 times du. So everything change, we know in the form of x, in the form of u. So I equal 7 times e to the power x is u plus 2 minus 8 divided by e to the power x plus minus 2 to squared is u squared. Times dx is 1 over u plus 2 du. Then simplified, integral 7u, if you remove the brackets, 7u plus 14 minus 8 divided by u squared times u plus 2 du. From that, 14 minus 8 is 6, so 7u plus 6, integral 7u plus 6 divided by u squared u plus 2 du. This is what we have been asked to prove. We have done. The second part, the integration of the upper limit is 6, so lower limit ln 6, so lower limit ln 4, e is 7 e to the power x minus 8 over e to the power x minus 2 squared dx. So it's the original function in x. But we know that original function in function change u in the first part. So let's all we haven't done the limits. The limits are given for x, so we need to find the limits for u. So u equal e to the power x minus 2. That's substitution. When x equal ln 6, the upper limit, u equal e to the power ln 6 minus 2. So 6 minus 2, so ln e to the power ln 6 is 6, 6 minus 2 is 4. The x equal ln 4, u equal e to the power ln 4 minus 2, e to the power ln 4 is 4, then minus 2 is 2. So the limits change for u. Those of you sort of wonder how we could get this e to the power ln 6 is 6. I'll just give you a little explanation. Say in case this is purely the logarithmic identities. So e to the power ln y, say e to the power ln y is just number x. That's what we need to find. X. Then if you take the log for both sides, ln e to the power ln y equal ln x. Then the power become times, so ln y times ln e equal ln x. Ln e is 1. So the base and the actual number is same, so 1. The log e to the base e is 1, log 10 to the base 10 is 1. So let e to the base is 1. So just ln y is ln x. So ln y is ln x. Remove the log. So y equal x. So whatever y, that's the value. So that's what it is. E to the power ln 6 is 6. E to the power ln 4 is 4. Right, let's come to the question. Is integral ln 4 ln 6 7e to the power x minus 8 divided by e to the power x minus 2 all things squared dx. So, but what we have inside the integral sign, we already proved it. So 7u plus 6 divided by u squared u plus 2 du. And the limit, we have changed it for u, that is 2 and 4. Upper limit 4, lower limit 2. So the function in the integral is to be a partial fraction in order to differentiate. So partial fraction on the left-hand side is whatever the function in the integration, 7u plus 6 divided by u plus 2. U squared times u plus 2. Then if you write that partial fraction, so we have u squared. So first order function or second order function, we need to split into first order in the order. How you do it? A over u and b over u squared. So for example, say u plus x, u plus b or something, u plus b to the power of 3. So we do a over u plus b, b over u plus b plus squared, c over u plus b cubed. Right, just let's not go into too far. So a over u, b over u squared plus c over u plus 2. The simple partial fraction format students should know. Right, if you take the LCM for right hand side, it's same as the left hand side. So I just removed it. Again, if you want to do it, you can do another step in between. So 7u plus 6 equal. So if you do that, a and u times u plus 2, a u times u plus 2, b u plus 2, c u squared. You can do that equating the coefficient of u functions, but I just want to use the Carab rule in order to do it. If you have the second order function, then of course we need to, we can only find the constant in the denominator of the second order function. So we can only find b and c. A, we need to do the conventional method of equating the coefficient. So Carab rule, just cover u squared. So in other words, u squared becomes 0, z equals 0. So b equal, on this left-hand side, cover the u squared and substitute the u for the rest. So 7 times 0 plus 6 divided by 0 plus 2. That is 6 over 2, 3. That is b equal 3. Then c, the same thing, the denominator u plus 2, just to make it 0, that u equal minus 2, and cover the u plus 2 on the left-hand side, and then substitute the value for the rest of the u's. 7 times minus 2 plus 6 over minus 2 squared. 7 times minus 2 is 14, minus 14 plus 6 over minus 2 squared, 4. So minus 14 plus 6 is minus 8. Divided by 4 is minus 2. C is minus 2. Then going back to the conventional method in this equation. So what that says, so we can look for the coefficient of u squared. So coefficient of u squared is here, a u squared and c u squared. So a plus c. And the left-hand side, there is no u squared, therefore the coefficient of u squared is 0. A plus c equals 0. From that, a equal 2, because of a equal minus c equal minus 2, therefore a equal 2. Right, let's write that again. Integral 2, 4, 7u plus 6, u squared, u plus 2, du. That is what we have to find. And we have found the partial fraction. The first one, integral 2, 4, 2 over u du, plus integral 2, 4, 3 over u squared du, plus integral 2, 4, minus 2, c is minus 2, minus 2 over u plus 2 du. The first one, u over, 2 is constant, 1 over u is log ln. So 2 ln u, the limits 4 and 2, plus the 3 constant, 1 over u squared is become, is u to the power of minus 2 if you take the denominator to the top, to the power minus 2. So integrate that is minus 1 over minus 1. So 3 times u to the power minus 1 divided by minus 1, the limit is 4, 2. And again, next one, u is constant, so minus 2 out, and ln u plus 2 limits. Right, apply the limits. Here the first one, the limits is ln 4 minus ln 2. That is, in logarithmic identity, ln 4 minus ln 2 is ln 4 over 2. So ln 4 over 2, ln 2. And then 3 times, and this u to the power minus 1 is 1 over u. First upper value, upper limit, 1 over 4 minus 1 over 2. And the third part, minus 2. Again, the ln 4 plus 2 is 6, divided by 4 plus 2 is 4. That is 6 over 4 is 3 over 2. That is this one. Right, here, let's look at the number first. The quarter minus half, that is minus quarter, and minus 3, that is plus 3 over 4. And then 2 ln 2, and here minus 3 over 2. So the take 2 out. What we have, ln 2 minus ln 3 over 2. So logarithmic identity, minus, therefore divide. So ln 2 over 3 over 2. That is, when you do that, the 2 go to the top. So 3 over 4, the first number, 2 times 4 over 3. That is 3 over 4 plus, then 2 become power. So it's 4 to the power of 6, 4 to the power of 2 is 16, and 3 to the power of 2 is 9. This is what it is. So A equal 3 over 4, B equal 16 over 9, because of the form they've given us, A plus ln B. So A is 3 over 4, B is 16 over 9. Thank you. Please subscribe to the channel and share the contents with your friends and other students. Thank you.